Hello students, welcome to the next video of real numbers for CBSE class 10. In the first video we have done the Euclid's division lemma and the sums related to that. In the second video, the session 2, it's upon the rational numbers. So in grade 9 we have done with the real rational numbers and irrational numbers part a lot. So we are just actually revising here. What is called rational numbers? The numbers, those you can write in the form p by q where p and q both are integers and the q, the denominator, cannot be 0. Those type of numbers are called the rational numbers. For example, you can take any whole number, that is 1 2 3 4, or any integer like -5, any number which is in a decimal form like 1.6, any negative number like -1.5, the fractions like 2 by 3 -2 by 3 or -5 3 by 4, all these are rational numbers because all of them can be written as in the form p by q and the q is not equals to 0. P by and q both are integers. Even this 1, maybe you are a little bit confused like how this can be written as 1. So the 1 actually can be written as 1 by 1, right? So this 1 can be written as 1 by 1, so it's an p by q form, right? So it's comparable to p by q, so that's why it's an rational number. Okay, next, we under this rational number we have two important observation. The observation one is these rational numbers can be two different types. First one is the rational number is terminating or it will be repeating decimals. So the rational numbers always either will be terminating or it will be repeating decimal. Repeating decimals. Then that means if you convert them into decimal form, the rational number always give you like 1.56. That's a terminating decimal because we can see the decimal is not going further. Or we can have 1.33333 and so on. That's a repeating decimal because the 3 is getting repeated each and every time, which we can even write it as 1.3 bar using the symbol of repetitions. That's the first observation we have. The second observation says if it is a repeating number, if the rational number is a repeating, so for for terminating numbers, terminating rational numbers, for terminating rational numbers, what we have for the terminating rational numbers, we have the denominator. If say this terminating rational numbers is in the form p by q, then the q must be in the form 2 to the power m into 5 to the power n, where m and n both are integers, where m and n are integers. So if it is a terminating rational number, then the denominator q we can write in the form 2 to the power m into 5 to the power n, and it's always true. That means if you know this trick, without actual division, you can say that the fraction, if you convert it into a decimal, it will be a terminating or it will be a repeating decimal. For say, we have an example for this. For say we have for say we have 17 by 90. 17 by 90. Okay, so let's do it. We have to check whether it is without actual division. We have to check whether it is a terminating or it is a non-terminating number. So we just need to take the denominator and we have to prime factorize it. So if you do for the prime factorization of 90, we can write 9 into 10, and that can be written as 3 square into 2 to the power 1 into 5 to the power 1, which is not in the form 2 to the power m into 5 to the power n. Why? Because we have the 3. It means if you prime factorize the denominator, you shouldn't have any other factor than 2 and 5. But we have 3 as a factor, even 2 3s. So it's more non-terminating numbers. This number is not a terminating number, it's a non-terminating number. Still, it is a rational number, but it is a non-terminating number. Why it is a rational number? Because we can convert it into the form 17 by 90, that is in the form p by q. That's why it's rational number, but it's not a terminating rational number. It's a non-terminating repeating number, because we have only one choice left, whether it is going to be repeating or not. So that this is how we can convert it into, we can check whether it is terminating or non-terminating. We have one other type of question from this particular observation, that without actual division, convert it into a decimal form. uh, this time they have given some terminating numbers. So say we have 17 by 625. So first what we can do, we can just convert it into the denominator. Let's convert it into the standard form, that is 2 to the power m into 5 to the power n. So obviously it's gonna be 5 to the power 4. Okay, so that 5 to the power 4 can be written as 17 into 2 to the power 4 divided by 5 to the power 4 into 2 to the power 4. Okay, what happens, we always need to convert, we always need to equate the power of the 2 and 4 that we 2 and 5 that we are having in the denominator. If your question is why, because we can convert 5 to the power 4 into 2 to the power 4 as 10 to the power 4, because we have the same power, different base, so bases will get multiplied. So 10 to the power 4, and 17 into 2 to the power 4 will give you 17 into 2 to the power 4 will give you, that means 17 into 16, 272. So that means we have 272 divided by 1 2 3 4, which we can simply convert it into a decimal form. It will be 0.0272. We just bring the decimal to the left side, four decimal places, so 0.0272. So these are the two type of problem for the terminating numbers. Now for the non-terminating repeating numbers, we so non-terminating repeating numbers, the example can be, you can say the example can be 0 0.6 bar, which you expand, you will be getting 0.666666. The question is to convert it into a simplest form. That means you have to convert it into a fraction, because as it is a rational number, it can be converted into the form p by q. So that's our objective. We have to convert it into a fraction. What happens, how we can do it, we will be taking x equals to 0 0.6 bar, or x equals to 0.666666 dot dot dot, such so on. Then we have to check after decimal how many places are having a bar, how many digits are having bar. In this case, 1. So we have to multiply this x by 10. If I have two digits having bars, so I have to multiply it by 100. If 3, then 1000. If 4, then 10,000. So if I multiply it by 10, I will be getting 6.66666 dot dot dot. So name it as equation 1 and this is as equation 2. So subtract equation 1 and equation 2. So that means 10x equals to 6.66666 and x equals to 0.6666666. And if you subtract them, you should have minus minus 9x equals to 6 because this entire part will get cancelled. So x equals to 6 by 9, which is 2 by 3. So that will be the fraction conversion. Okay. In the same way, let's do another question. It's a bit different. Here we will be doing x equals to 0.254, but bar is only f of 54. In this case, it's same as the previous one, but only one step you have to do extra, that you have to bring the 2 this side and then repeat the previous method. To bring the 2 this side, we just need to multiply it by 10. So 10x equals to 2.54 bar. Now I can just do it in the way, that is by multiplying it by some numbers and so on. So this is the expanded form. You multiply this by how much? 100, because we have two digits with bar. So 100 times 10x, not 100 times x, it's 100 times 10x, and 100 times 2.54545454 and so on. So that means we have 1000, x equals to 254.545454 and so on. Name this as equation 1 and this 10x one the equation 2. We should forget the first equation, that x equals to something, and subtract the equation 1 and equation 2. So that means 1000 x equals 254.545454 and so on, minus 10x equals to 2.545454 and so on. So let's subtract it. 900x equals to 252. That means you can say that x equals to 252 by 900. And if you simplify it, 252 by 900, it will give you, sorry, it's not 900, it's 990. 990. So if I simplify it, I should get 14 by 55. This is the way you can solve the questions related to the rational numbers. One other type of questions we have here, they will be providing you two different numbers and you have to check whether they are rational or not rational. So say we have 0.144, 144, 144, 144 and so on. And say the question number 2 is given 0.14, 144, 144, 14444, 1 and so on. The question is which one out of these two, which one is a rational number? So if you look it carefully, you can simply say this is a rational number. It's a rational number because it's in repeating decimal. You can write it as 0.144 bar. But here we can see lot of fours and lot of ones, and we can see a pattern that's 1 4 and 1 once 1 and once 4, then once 1 twice 4, once 1 3 times 4, once 1 4 times 4. So obviously after 1 there will be 5 times of 4, but we can't have any particular repetition. It's an irregular figure, so not a rational number. Okay, it will be an irrational number, about which we will be discussing in the next video. It will be an irrational number. We'll be discussing about it in the next video, that what is irrational number, how to identify, and how to solve related to the irrational number portion. Okay, thanks for watching the video. Don't forget to subscribe, like, and share the videos with your friends. Do comment if you have any other doubt. If you want any other thing need to be solved, you can comment into you can tell me into the context comment section. And I also provide one-to-one session for the students who require. I have few YouTube students who used to take a regular session with me, so you can join with them. It's one-to-one private session. If you have any doubts on some topics need to be cleared other than these videos. Thank you.